Okay. So I don't have to ask. I think everybody can see the screen. I guess in the chat, you don't have to rejoin. You want me to start now, or should I wait till 13:05?
Oh, okay. Our session technically starts at 13:05. Yeah, that's up to you. We can wait a few minutes if you want.
I mean, I've got plenty to cover. I don't know. Do we have people entering?
There might be some people that trickle in.
Maybe I'll split the difference in at 104.
Sounds fair.
Since this was a impromptu, added it because it looked like there were openings on the board. So
yeah, I'm glad I refreshed the page. I actually thought I was not moderating this half hour, and then I saw it come up, and I actually was really excited because I actually used to study neuroscience, so I'm definitely interested in hearing what you have to say about this.
It can be very small bit of neuroscience.
Yeah, I studied it briefly, so I'm not by any means an expert.
That might be title bait. Okay. Well, I can go ahead and dive in. I'll start. So thanks for those of you who are attending, sticking it out. I'm super impressed with the Remo platform. So if you got questions, throw them in the Q&A. I recognize I am now head-to-head with a session on data storytelling with Power BI on homelessness, which looked like a very, very intriguing session. So if I get 5 minutes into this and you are thinking nothing new here, I will not be offended if you bail and hop to that one or otherwise. But thanks for sticking it out. So we're going to talk about data visualization. Going to run through a pretty good chunk of content pretty quickly. I throw in kind of the neuroscience piece because I think that's kind of a clear sort of core thing we need to recognize. That when we talk about data visualization, it is not we're just trying to make things pretty. I'm not a designer. I don't have design talent. Why are you asking me, the analyst, to make the data pretty? Because it's not at all, that's not the point of learning principles of data visualization. It's about being understood. And if you think about what being understood means, that means that we need to get the information we're conveying into the brains of our audience, and we want them to actually understand, retain, and be able to recall the information that we're presenting. And so if you think about understanding, retaining, and recalling, well, we're talking about the brain. So really, data visualization is fundamentally, to me, about the brain and how it works. Tons of things we don't understand about how the brain works, paraphrasing John Medina, brain rules on this, but there are some things that we do. And one of the things that comes up again and again with people who are looking into exploring and studying data visualization is the three types of memory that are there. That the neuroscientists have kind of identified, or psychologists. We've got iconic memory. That's the visual sensory register. That's where precognition happens. So all the light that is occurring right now that is entering your pupil and hitting your retina is being precognitively processed. If there's a flash of light off in your peripheral vision, you will turn and look at that without thinking of it because everything is coming in. A tiny, tiny little fraction of that actually goes into short-term memory. Short-term memory is where cognition happens. The problem is short-term memory has an insanely limited capacity. So Miller's Law, if you've heard of that, gets talked about in various circles. George Miller, 1956 study. It's been kind of come out a few different ways, but he posited that our short-term memory can only handle 7 ± 2 chunks of information simultaneously. So think of that as a computer with very, very, very little RAM. Other studies have come at it, and if anything, they think this is being a little aggressive. So is it really 7? Is it really 4? Is it really 1? So what is a chunk of information? So even Miller kind of recognized that was a little squishy. So that's where our brain starts to do things to try to take a sea of information and kind of turn it into chunks. But just keep in mind that super, super limited capacity. Where we actually want to get our audience to retain something is long-term memory, because long-term memory is everything that we retain through tomorrow, through next week, through a month, to a year from now. And if we want users to take the information we're giving to them and understand it and then store it and then retrieve it so they can act on it, we have to get information into long-term memory. So to me, data visualization is really all about kind of streamlining and understanding that process, reducing the cognitive load we're putting on our audience so that they can actually take in the information, process it, retain it, and then use it later. To give kind of a practical example, this may permanently be my favorite example. It's out of Stephen Few has an information dashboard design where if I ask you the question, how many 5s are in this list? And if you're looking at it, maybe this is where you make your screen full screen so you're not seeing me half and half. Look at this and yeah, you can figure it out. But what if instead I said how many 5s are in this list? And assuming that I'm trying to convey that clearly, you can get to 6 much, much, much more easily. So that was a relatively subtle visualization presentation tweak that I made, but I drastically reduced the cognitive load in order for you to process that information. To take a slightly more practical example, so this is kind of a mashup of defaults from Google Sheets and Excel, and there are a ton of things that are adding cognitive load to this. There are a ton of things our brain has to subconsciously discard as being not important. The border, no information there. The shadow, I have to take those in, but then I have to discard and say, nope, those don't actually matter. When we tilt text, studies have been done that show that slows down our ability to process because we're adding a load. Our brain in the Western world, we read top to bottom, left to right. Our brain has to rotate that to horizontal before it can actually take it in. It's even worse when you actually do vertical text. Sometimes you have to, but you kind of want to avoid it. And grid lines. So a lot of times charts will have default grid lines, and which of those are needed? They often need to be kind of looked at. You kind of understand why they're there, but they're not actually conveying information. We've got redundant information. Once we've already gone through the work of figuring out January, February, March, April, we already know that it's the month. So this is redundant. I can discard that. It's information I already knew. The same thing for having, this is a pretty egregious chart, but having a legend, we only have one series of data. We've already represented that in the title and in the y-axis title. So we don't need that. So if we actually instead looked at the chart this way, we have removed all of that cognitive load. Still not a beautiful or super insightful chart, but much, much easier to read. And all that was doing was reducing cognitive load, not trying to make it pretty. So that's kind of the theory. I want to hit some quick tips. We only have a brief amount of time, but a few tips on things you can specifically do that are very, very tactical to actually improve reduce the cognitive load of your charts. So Stephen Few, so he's kind of a disciple of Edward Tufte, but to me, Stephen Few was the take Tufte's ideas and concepts and make them much, much more practical for the real world. And this kind of mantra of his, maximize the data pixel ratio, which he took from Tufte's maximize the data ink ratio, to me is the single tip that will improve your data visualizations tremendously. So what is it? Well, it's kind of a weird thing to explain, but it's a pretty simple idea. What Few says is everything on a screen that is not a background pixel. So you've got your background color, whether it's white or black or blue, and every other pixel is a non-background pixel, is either representing data and information or it's not. It's just structural or it's decorative. And what you want to do is you want to have as many of your non-background pixels as possible be representing data and information. And you want to minimize anything that is just decorative or structural. So so you don't ever really calculate this ratio. It's just kind of a concept, an ideal that you're marching towards. I used to do training with a lady named Michelle Kiss, and she was like, why do you always want to call it maximize the data pixel ratio? That's this really arcane, weird way to describe it. Why don't you just say, pretend your printer is running out of ink, which is also totally fair. I've got 10 pages of analysis I need to print out. I'm going to run out of ink at any point. What do? I start removing the stuff that's unessential. Cole Affleck says declutter. They're all pointing to the same thing, which is heavy up the data, lighten up or remove the non-data. So that was a big chunk of what we did in this example. If you look at it, the things like the border, the shadow, the extraneous X and Y axis titles, the legend, those are all not actually conveying data or information. They've been removed. There's another little subtle thing you probably didn't catch when I did the transformation earlier. I actually heavied up my line of data. But then also here, even the The labels, we need them. You can't strip off everything. I need the y-axis labels. I need the x-axis labels, but I can lighten those up because that's not the actual data. So I want to make the data come forward. I want to push everything else back that is just a reference or structural information. And I want to remove stuff that is completely gratuitous. This is an example with a chart. It totally works with tables of data as well. Our tendency is if we pull data out of a spreadsheet and we say we want to make this professional, our tendency is to add stuff to it. What can we add to that? Let's invert the heading, the titles. Let's maybe heavy up the border. And that is kind of the opposite of what we want to do. Instead, we want to remove things. We want to lessen things, let the data itself come to the fore a little bit. Sometimes we actually want to have like a horizontal line to help with readability. It's kind of a judgment call depending on the size of the data, of the table, and how it's being presented. But even that, if we're putting in a horizontal line, that is not data. It is kind of there just for structure. We want to make it as light as possibly possible. So it's kind of illegal, international law, to talk about data visualization and not beat up on pie charts. I could talk for an hour and a half about why pie charts are bad. If we look at it just through this cognitive load lens, we will. Tim did not turn off notifications, or I saw Gotham said something, but I don't know what. There's a lot of cognitive load to reading a pie chart, especially one that has a legend on it. Our eyes have to bounce back and forth. We're trying to simultaneously hold multiple things in our brain at once. Color is problematic. Comparing areas is problematic. There are lots of reasons that pie charts are really, really challenging. If instead we just do a horizontal bar chart, maybe it's easier for us to read top to bottom. We can see the comparisons of the areas where our eyes aren't having to bounce back and forth because we've got everything kind of labeled proximately. Or we could even make it be the straight up percentages. So representing the exact same thing, there is a downside of horizontal bar charts. They don't represent that these are parts of a whole. That is one advantage of a pie chart, but more often than not, a horizontal bar chart serves us much, much better than a pie chart. This is something I've railed on for now over a decade. That's what that little bit.ly was a post from years ago. A lot of vendors found out, they realized that, pie charts are getting knocked. So they updated their tools and said, now we have donut charts. Donuts are just as bad. They might be worse. I don't know if a donut chart, if you're supposed to be comparing the length of the arcs or the areas of the arcs. I'm not even sure what exactly you're comparing. I know in Data Studio, to make a donut chart, you just specify how big you want your circle. So I should be able to figure out that math. But donut charts look a little more modern. They're just as bad. Maybe it can be okay to have pie charts if you've got plenty of room, because they're also kind of real estate hogs. They can be okay if you've only got 2 or 3 sections that you're using. This one is actually not okay. So this is a way to sneak in the problem of color. Relying solely on color to represent something, you do run into 9 to 10% of U.S. males. Supposedly, I have struggled to track down the actual source of this, but I definitely know people who have red-green color blindness, and you can wind up making something completely unreadable. I know an analyst who actually had a boss who had this and went for a few months giving him a report, where his boss finally said, I cannot read this because it's red and green. Even outside of color blindness, we've got people who are working from home and have a black and white printer and occasionally want to print something out because it's a cheap laser printer, and they're going to struggle with this as well. So there are a couple tools out there. Sim Daltonism is a free app for Mac that I love. It gives you a lens and you can just kind of pop it over and see if you're running into a color blindness challenge. There's also Color Oracle for both Windows and Mac, although I've never gotten it to work on my Mac. It supposedly does. So I've already said horizontal bar charts are, I like them. Generally, that's almost my default for categorical data. Horizontal bar charts generally have a lot going for them. And generally doing horizontal bar charts with a neutral background color. So we start with kind of whatever is a neutral light color is kind of a good starting spot. And then we use color for accent. But notice with horizontal bar charts, you can do metric comparisons side by side pretty easily. You don't have to repeat the labels. Very easy for someone to scan and understand these. And again, processing chunks of information, the way the brain kind of is going to, what happens is it will jump to finding things that are breaks in the pattern. In this case, display looks like a break in the pattern because it's got this really high bounce rate, because display is generally terrible. So we actually can see that very, very easily. If that's the point we're really, really trying to make, that's where we can start bringing in color to really accent it. Now it's completely unambiguous. I am minimizing the cognitive load because I am suppressing everything to, I'm driving the eye straight to, this is what I'm actually want you to look at. So I'm making it as easy as possible for the brain to figure that out and interpret it. So horizontal bar charts work in table form as well. So this is, I've added one column of data, but this is basically the table we looked at earlier as well as the bar charts earlier. Notice that it's harder to find that 97%. This is showing the same thing in the second and third column as those charts were, but we actually have to read those numbers and process those numbers to realize that bounce rate is so much higher. If instead of adding all that cognitive load, I can represent this by using horizontal bars, in-cell bars. I don't like to put them on top of the numbers. That's kind of taxing on the brain, but putting them right next to it, add a column, and then with conditional formatting in Excel, with Sparklines in Google Sheets, you can do this in Data Studio. Pretty easy to kind of drop this in. With Sparklines, with Google Sheets, this is really cool because you can have it dynamically change which one you want it to highlight. It's a little tougher to do that in Excel. But now our eye goes straight to I'm guiding it straight to, this is what I want you to look at. You're getting a sense of kind of the magnitude, and then your brain can hone in on the specific numbers if needed. I kind of get irritated when people take things straight out of any platform and just show the variable names. Take CPC. That requires somebody to say, I understand that CPC is cost per click, and that is my paid search spend, potentially. Put in a little lookup table, or take the care to say, let's make this as easy and comprehensible as possible. Definitely want to include the data source. So that's borderline not really a data visualization tip, but maybe it's a pet peeve that I want to tout. What was the data source? What was the time frame? What was the core information? Yep, this is diminishing this is lowering the data pixel ratio in a slide format, but it's worthwhile. We put it small, we put it relatively light, we put it out of the way in the bottom left corner, but now we've got it where nobody's going to say, wait a minute, what is this data actually, where's this from? When was it actually taken? Another classic data visualization, we've got a lot of significant digits here, and there are some platforms that just drop these on every possible time. Way, way, way too many zeros. This is the old precision versus accuracy, highly precise. If we're looking at A/B test results, this may be factually accurate, but we know that is not a good way to represent that we've got that level of fidelity within what's really going on. So definitely on our y-axis, we want to really drop the extra zeros. Again, maximizing the data pixel ratio, and then be deliberate on how many decimals we're including with our actual labels. Could even, in this case, kill the y-axis, maximize the data pixel ratio completely. People are going to assume that there is a zero-based y-axis, which there almost always should be. So now we've got a much, much, much cleaner chart. Compare that to this versus this. Sometimes we actually want to, if we're trying to say, hey, this one did better than the other one, error bars introduce a little bit of cognitive load, but they actually are they may be very appropriate, and our audience will understand that, oh, what you're telling me is that there's some variability, there's some squishiness in this. So really thinking through, or that if we need to represent uncertainty, we should. That may be worth having a little bit of extra cognitive load. So we just did a bunch of bar charts. That is not the only type of data visualization. Certainly, it's not just pick your horizontal or your vertical. There are other visualizations, but we always want to start with the basic ones. So I've had analysts tell me, well, gee, I'd used 4 horizontal bar charts in a row in this presentation. I just wanted to mix it up. I wanted to try something, just put in something different to make it visually interesting. That is almost always a terrible idea. If anything, using the same consistent visualization type helps the audience actually understand how you're presenting stuff. So this idea of like mix it up to make it interesting drives me up the wall. I have snapped at a few clients, which is not generally considered a wise thing to do when they have rattled off things like this. So there are these chart selectors. This extreme presentation method thing has been around for years, over 10 years. I don't actually ever think through that I'm making a chart by going through this sort of logical flow, but I do think it's kind of useful to actually make sure you're comfortable with the ones that are around the periphery, that you would recognize when a waterfall chart would be appropriate, or a scatter plot. Or maybe even a spider diagram, or what they call here a circular area chart, which is almost never appropriate. There's also an online version, also been around for a very long time, almost the identical concept. Again, it's useful just to know what types of charts are out there, and then knowing that if we're going to use one, we should be very deliberate about it. Know that we're often introducing additional cognitive load. It may be appropriate, it may be the best we want to give, but we need to give our audience time to digest it. So I love Sparklines. So they are just a line chart. So let's just say we're not going to talk about line charts, which for time series data, they're great. The Sparkline, a special type of line chart, really, really useful. If you're presenting like a dashboard and you've got KPIs, you want to show the main metric, and then you may want some other little context. And then there is a legitimate need to say, well, but is stuff trending upward? Is it trending downward? Was there a big spike? So Sparklines remove a whole lot of information, but they include that what was the pattern of the data over whatever time period I was looking at. So Sparklines are kind of awesome because they're really compact. They are data, so they're actually not, they're helping your data pixel ratio, but they're not dominating and requiring a whole lot of real estate. The same thing I'd like to call out, the numbers, the actual numbers, the data being represented in number format, that's a data visualization, especially if you start adding in the text size. You may often be presenting a metric and say, I have the metric, but I also need to represent what its target was, how it compares to that target, all this other context. I need these other little numbers. It's great. Separate them. Pick which is the main number, and then don't just do like one at 16 point and the other one's at 14 point. Go big. Make it twice as big to make it easy on the brain to say, this is what I'm looking at first. The others are just kind of reference and contextual information for that. Bar charts. Here's another example of a bar chart, and this is kind of a multi-series bar chart. And these, I think, are some of often the hardest things to read. So if you look at this one, there is one of these is not like the other, and it's organic search. It has gone down year over year from 2018 to 2019, while everything else went up. But we had to work pretty hard to actually find that and figure it out. This is a great example where a slope graph would be awesome. Slope graph is just a special type of line chart with just 2 points. And with this, you look at it and you immediately see that organic search looks different. It's crossing stuff because it's going in a different direction. If that's really the point that I'm trying to make, I can go back to using my friend color and make everything else gray. And now it's completely unambiguous, very, very easy to understand, even if the slope graph is a little bit of a foreign concept to our audience. Heat maps can be amazing. Like Google Analytics on their web interface has had it for years, day of week, hour of day. It's a great way to kind of draw the eye to where are there pockets of things that are higher or lower than others. I like to use heat maps in representing tables of data. They can also help kind of draw the eye to what's good, what's bad. Now this one, if you're watching it thinking, wait a minute, isn't this one terrible? Why, yes, it is terrible. It's terrible because it looks good and bad look the same to somebody with deuteranopia. So instead, we generally want to go with a monochromatic scale. If I have to have a good and a bad, if I'm going to positive numbers and negative numbers, something that's more around blues and yellows or oranges are kind of better. Again, adds a little cognitive load because most people are used to kind of the red-green, but still kind of makes it a little more universally available. But this really draws the eyes to, now I can give the hard data, but I can also kind of give visual clues as to where the real scale or magnitude is. So lots of other types. I love Venn diagrams when it comes to comparing segments. I love word clouds if they're done well. Box plots showing variability. Waterfall charts if we're trying to break down how did something change between X and Y. What were the components going into that? Scatter plots. Lots of these are great, but at the end of the day, we're trying to reduce cognitive load for our audience. This is good. I see a few questions that I have not read yet, but we're just about to the point where I'll tackle those. So for years, this middle book, Information Dashboard Design, even though it says it's about dashboards, to me, it was kind of my Bible for data visualization. It's still a great book, but I will say that earlier this year, I finally got around to reading Storytelling with Data by Cole Knaflick, and it is amazing. I kind of feel like it should be required reading for any analyst who has to work with me. It will make their lives a lot less painful, and it will make their work immensely better. She hits everything we just covered and more, and going into more depth, not in lightning speed. We have not talked about data storytelling, which is kind of a separate topic. I'm about to have an animation on here that does not apply to this because I realized I just used this earlier this week. But Nancy Duarte, if you know her from Slatology or Resonate, she's kind of a presentation guru. Brent Dykes comes from a digital analytics background. He used to work at Omniture, then Adobe, and then Domo. Both have great books out in the last year on data storytelling. Brent is not going to be on that. And I will plug the Digital Analytics Power Hour podcast because that's on this screen, and we will turn to questions. So I'll just run from the top. We'll start with Neil's question. You ever considered the idea of making unreliable data harder to read? Example, your opacity is linked to your p-value. Has anyone done this concept well? Wow. I don't know about X. I think I'd be more with trying to make it's an intriguing concept. I think I'd be more likely to make it, harder to read. Maybe the harder to read means I'm going to make somebody have to work harder to see it. I would be more inclined to do a visual treatment that shows that it is less reliable. It's one of the reasons I kind of like error bars and box plots in certain cases. But it's interesting actually doing a scaled, whether it's opacity or a gradient, of saying, actually what you've got here, the p-value, that's fascinating. If I was going to have a table where I had different p-values for whatever data I'm representing and making the lightness of that's fascinating. I like that one. I'm going to have to think about that. Alban, is reducing cognitive load a slippery slope when building up exposure to data slowly can lead to building data literacy muscle? I guess, but I had a wise woman once said when I was trying to say you need to educate your audience when you're presenting the results of an A/B test. We need to teach them why you can't just annualize the revenue impact. And she was like, Tim, how much exactly do you want to accomplish in this one thing? Are you trying to convey the results, or are you trying to teach statistics to the audience? And so this was Val Kroll. And that has really stuck with me because I'm not sure that trying to build data literacy muscle, when I'm communicating information, I think my primary goal is to communicate the information clearly. And I think I would want to pursue other avenues for kind of building data literacy muscle. And then even the topic of data literacy is so broad that, but it's interesting. I think putting things in like an error bar and saying, look, this is representing, plus or minus one standard error. Not going to go into detail of that. Just know that it's uncertainty or it's variable. I could see blending that in. The stacked horizontal bar chart, I try to avoid, but it's a good question from Kevin because like the knock with any stacked chart is always that the first series, you can see what's happening over time in comparison with that. And then every other wedge is really tough for the eye. So small multiples, which we didn't talk about here, it was sort of like the example of the two horizontal bars. I tend to prefer doing that, saying split it out into multiple charts that share the share, if they're vertical, share the x-axis so that the comparison can still be made, but I can actually see what's happening within the data. Could cognitive load be the expression of the famous, this is going to be a beauty. The famous Upton Sinclair quote, it's hard to make people see what they need to when their salary depends upon their lack of understanding. Yeah, that's a good point. If somebody really cares about the information, they will be more likely to think about it hard. So I think this is kind of a cousin to your first question. You do want your audience to care. Where are you meeting them? Are you meeting them more than halfway? This is like a deep philosophical question. Emily, I have some stakeholders who are primarily motivated by how pretty the presentation is. I underestimated this for too long in my career. I will go back to, I had a argument with the guy who was an analyst at an agency, and he was adamant that our clients wanted stuff to be pretty. That we were an agency, and by golly, the stuff needed to be presented to them. It needed to be pretty, and to him, his definition of pretty was adding a bunch of crap to it. But he was also not following good data visualization principles even outside of that. And I basically said, fine, let me take it. I'm going to apply these principles. I'm not worrying at all about making it pretty. And then when I presented it internally, what I was told was, wow, your dashboard is so much prettier than those other ones that we've historically produced. So I believe that doing this well, if you look at the elegance of what 538.com does, I didn't call out Donna Wong's book, The Wall Street Journal Information Guide to Graphics. If you look at how some of those sites do things, they are not making stuff pretty. They're making it clear, and yet it feels more professional. So I think when there's care around using a palette that matches the corporate palette, the words are well put, there's a little bit of gray, not everything's black and harsh. I get feedback pretty regularly that my data visualizations are prettier, but they're really just cleaner and more comprehensible. So I tend to kind of question when somebody says they want pretty, you can kind of kill two birds with one stone. We have 1 minute left. Will the book recommendation be available somewhere to get that list with them? Some notes why one might be read over the other. I don't know. You can certainly reach out to me and I can provide my thoughts on that. I think we're about out of time. I really think, to me, if you're going to read one book, it would be Cole Knaflich's. She gets into storytelling at the very, very end of hers for pure data visualization at this point, just because it's so comprehensive. Nancy Duarte, she is just a presentation. I almost feel like her Slideology or Resonate or maybe, this is tough. Yeah, I don't know that I can actually say which one or the other would be better to read. I feel like I should have my moderator jumping in. I'm right in thinking this is supposed to be done right now.
Jim,
right?
If you need me to jump in with anything, let me know. But I think we're out of time for this. That was extremely valuable. I definitely wrote down some notes about books, information on data visualization, and I'll personally reach out to you on LinkedIn about some of those books. I think the next session is starting in 5 minutes in this room. I don't see any other sessions in the conference during this time slot, so people are welcome to just kind of stay here and hang out and continue the conversation until I guess Peter shows up. Peter will be here for his talk, Analytics Therapy, where we can all just kind of vent. It sounds like sharing biggest frustrations, and there are a lot. So
just to chime in real quick, they have actually added sessions. So if you check the session board again, there are 4 sessions going on at 22.
Nate, thank you for that update. I got to keep refreshing my tab here.
Yeah, that's what I've been doing. Just keep hitting refresh.
Yeah, thanks.
Okay, so discard what I said. I made an error in judgment.
Well, you can probably kick me off the stage. Although Peter would probably enjoy kicking me off the stage when he arrives, even more so.
Okay. Yeah, I don't know if I just need to. Oh, I can just click present, I guess. I'll stop presentation then. Thanks, Tim.
Awesome.